Okay, so I think it's probably about time to start. Can everyone hear me?
Yes.
Yeah. Excellent. Okay, this is entitled Object-Oriented Programming, Why You're Doing It Wrong. I think if I'd chosen a less controversial title, you would be here.
We're all insecure.
I think it must be a Neapolitan of incremental improvements. Okay, this is me. I've worn a striped shirt so you can recognise me from my photo. These are some of the modules I've written, which are on CPAN, but we talk about any of them today anyway. And the room is possessed by an angry spirit. Okay, most of the examples in this presentation are going to use Moo, which is basically a lightweight version of Moose. So who's used Moo or Moose or Mouse? Most people like that. Explain the examples so much. As I say, I'm using Moo in the examples, but you could rewrite the choose Moose with very few changes. And because Moose and Moo aren't that magic, you could rewrite and just use core, Perl, OO, less, sort of thing. Okay. Mutable state is considered harmful. This is the traditional Perl best practices way of doing an access of a piece of object data. You have a get food, set food. So this is an example. The standard loose way is a bit different, so that when you get separate guess and set methods, you can have just one method, and depending on whether you call it an argument or not, it acts as a setup. You can still do the get set thing with Moose, but these are both wrong. Okay, this is the problem with it. Here you've got basically two objects, Bob and Alice, and they're both pointing to the same pony object. So when you rename Alice's pony, it also renames Bob's pony, which is possibly not what you want. Might be what you want. And here's another example. We've got a keynote speech at the beginning of the conference. You decide to leave it, but you accidentally change conference start time because they're both pointing at the same object. So, to resolve this, you can, the best way to do it is to make your access as read-only so that if an object can't be updated, then you don't have any problems with spooky actions at distance. You can validate all the incoming information in the constructor for the object, and then you don't need to worry about it changing later and becoming invalid. In Moose or Moo, you just use is.ro, and that will make your accessor just become a read-only accessor, and you don't need to worry about people trying to change it. They can circumvent things and peek directly into the hash ref, and then they can change it, obviously, but then they've made their own bed, so any problems they have is their own fault. And if you're not using Moo or Moose, that's the very, very concise way of doing an accessor for an object attribute, which is read-only. But sometimes you do actually need objects which can change because the universe changes, and you sometimes use a model that the universe has changed. So here, we've got the same example again, and we're changing the name of the pony, and we actually want it to update Bob. In this case, you can actually change the name of the writer that Moose provides, or Moo, and you can give it something which sounds more like an action, like I'm actually doing something to this object. You're not just setting a variable, we're actually doing something to the object. And it makes it a bit clearer when you're reading your code that something's happening, could have global effects. So if you really need to change model changing world, you can make it, but only as a sort of last resort, and try not to change things which actually changes what the object is. You can change someone's name, that's fine, people do change names, but it doesn't change who they are. And so you've got to look at which attributes your object has that make it intrinsically what it is, and try to keep them read-only for sure. And with things which are less about what an object's identity is, you have a bit more wiggle room. You can actually make a few read-write attributes. And yeah, consider reading the writer method, something to make it obvious that you're actually doing something to the object. Okay, so there's a convention in the Perl world of using a leading underscore to indicate a method which is private. Problem is, it's not really private because a subclass can call it, a subclass can override it, and sometimes they'll even do so accidentally. Here's an example. I'll give you a few seconds to look at that. See, there's nothing particularly strange going on there, is there? My name is whoever. I'm an employee. This is a subclass of that same class which we defined before. We're saying typist named Moneypenny, and she's going to introduce herself. Introduce herself was defined in the previous one. But we get this strange can't call method press button on the identified value, line 16. Then you actually need to look at typist, line 16, and see what that is. Okay, so it's got keyboard press button, that's line 16. Keyboard is being passed into that method. It's the first parameter, which comes from self-default keyboard. Self-default keyboard seems to be an object which has just been built. That should throw an exception if it's not being built. So how's KB if that's undefined there? The problem is, going back up, you can see there's a method here with the same name being called with no parameters. And because it's undocumented, because it's a private method, the person who wrote the typist class didn't know it existed because it wasn't documented. So, here's some ways that you can avoid creating these underscore methods. This is our base employee class again. You can change it to a code ref. If you put it there, then it's in the my variable, can't be accessed outside this package definition. You can call it up, get the mouse to click. Call it just there. It's easy to call a method, a code ref as a method, just like that. It takes parameters, you just put parentheses and arguments there. The other alternative is to just make it a public method. If it's so useful that you've written it, then document it, let other people use it. So private methods can be promoted to public, or they can just be turned into code refs, so you don't need any subs which are underscore, named with an underscore, undocumented subs. If you're looking at doing attributes, as in bits of... Is that 10 minutes ago? 10 minutes?
10 to go. We started like this.
It's only 20 minutes, isn't it? So it's the same, 10 minutes ago. Okay. So also, if you need to do attributes with the same, which are also lexically accessed, you can use lexical accessor, which is modular I wrote. I'm not going to talk about that much, but I'm just going to say it's there. Hard coding things. Here's a method in an authorization type module. Fairly basic. Did anyone watch the HTTP client thing? So there's a fairly, you probably saw something similar to this up there. The bit where someone has hard-coded a user agent. The problem is that sometimes you need custom user agent types which has been set with certain SSL verification parameters or certain passwords built into it, that sort of thing. So you don't want to hard-code the user agent or the URL, which is obviously, that's the kind of obvious thing which has been hard-coded there. So this is what you might want to do in a subclass of the myauth module using a different user agent. And to do that, we've had to override the entire fetch user list methods. It'd be nice if we didn't have to override all the logic in that method. There's not a lot of logic in that method, I grant you. But anyway, this is a way to do it. Here we've created attributes, user agent and user list URL attributes, and you can just pass in an alternative user agent or an alternative URL in the object constructor, then it's made this method a lot smaller, a lot simpler, and it's made it a lot more reusable. And here's two examples of subclasses of that initial class. One which overrides the user agent, one which overrides the URL. And they're much easier. We don't need to override the entire fetch user list method. Here's one which overrides both. So it makes it easier to test if you need to add in a different user agent for testing, one which has extra logging capabilities, that sort of thing. If you need to use a different URL for testing, one which has a certain predefined list of users which you use for testing. And it makes it easier to extend if you need to create a different version of your software for a particular client. Here are some things that might be hard coding without even thinking about it. Things like file paths, including config files. It might be more useful if you could pass a config file as a parameter rather than having hard code it. Object instances, that's the user agent example. And class names. Sometimes when one class needs to create instances of another class, it'd be useful to pass that class name, that second class name, into the object. So that's the principle of dependency injection anyway. Okay, so these are the things I've covered: mutable objects, private methods, and hard-coded things. And these are the ways to work around them. Use read-only accessors, avoid undocumented methods. You can either put them into a full public documented interface or make them code refs so that people can't accidentally override them. And they can still deliberately override them probably if they use padlock or something like that. And stop hard coding things and use builders and things like that to make it easy to pass in the objects which you need. And that's it. Does there have any questions?
So could you just flick back to this slide where you give the example code rep for the private method alternative?
There.
Yeah.
So yeah, code ref can just be called like any other methods. It's just a scalar variable, put it after the arrow sign, and it can be used. You can also use a type here is a code ref, obviously, which you find up there, but it can also be a string, which is the name of the method. Anything else? Okay.
So now we made our attributes read-only, but what do we do if I actually need an object with this is just one value change?
That's what I said. You can, if there is something which you know should be safe to change, something which isn't going to change the identity of the object. For example, say you've got a daytime object. If you change the actual instance which it represents, then and other things are pointing at that object, then that's less than ideal because they'll be updated as well. But if you change the formatting of it, so it's example in an ISO format rather than RFC 3339, then that's probably less likely to cause bugs, but it still could cause bugs. So just try to avoid try to design your software to avoid that sort of problem. And you can always create a clone method on the object. So if you do need to change it, just create a clone of it, change the clone, and the things which are pointing to the old object doesn't matter because that's not been changed.
Have you come across daytime moonpick pictures?
Yes, I have. That solves a lot of problems with the daytime class. So daytime moonpick. It's kind of a strange name, but it's a slightly fixed version of daytime SPDI.
Did you ever consider making Moose objects immutable by default?
Well, I didn't write Moose, so
It has to have been an argument.
I think there is a strong argument for doing that because right now there is no default for Moose attributes. You have to say it's either read write or read only. You have to put it explicitly. they was going to be a default, I would hope that that would be the default they choose.
Or there.
What, sorry?
Or there.
There, possibly, yeah. Their Moose attributes
Just
does do the constructor
because otherwise
initialization.
people tend to go through your attribute to get to a reference to an object and then fuck around with the object you didn't want them to
Yes.
touch with, so use there and delegation to stop them.
That's definitely possible as well, yeah. Anything else? Okay.
Dependency injection with Threadboard. The subject of my lightning talk later.
Dependency injection, which is the stop hard coding things, goes to the threadboard lightning talk. Anything else?
Yeah.
Yeah.
Does the thing with the probe for code refs give you the same level of speed when executing?
It can be slightly faster, I think, because there's no inheritance to take into account. It doesn't need to walk up parent classes. But it's not likely to make an awful lot of difference either way. Anything else? No? That's it.